Okay, let's look at question 6. Question 6 is still dealing with trigonometry, and I love these kind of questions because they really test your understanding of your identities and then also just maths in general. Okay, just your rules. So question 6.1 says, given that cos of a minus alpha minus beta equals cos alpha cos beta plus sine alpha sine beta, use the given identity to derive the formula for cos alpha plus beta. Okay, so let's have a look there. They've given us that over there, so we've got to use this identity in some given way. Okay, now we know that this is going to be the negative version, but you have to use what's given to you. So they want you to show the following. Now we know that a positive is created by a negative multiplied by a negative. Okay, or minus minus. So they want you to show this cos of alpha minus beta. Okay, once you have that, we can now use the identity, which is then going to be equal to cos of alpha cos of minus beta, okay, then plus sine of alpha sine of minus beta. Okay, so now that we have that, now we can use our rules for cos, our identities, and then for sine as well. So we know that cos of any negative angle is just going to give us a positive cos. So this is just going to be cos of alpha cos of beta. Okay, then we know that, okay, so we'll do one at a time, sine of alpha sine of minus beta. Now we know that sine of beta, negative beta, is going to give us negative sine of beta. Okay, so therefore we'll have cos of alpha cos of beta minus, because now this turns into a negative, so I'm taking that negative timesing by this positive, then it's going to give us minus sine, wait, let me do it this way so I can show you. Sine alpha multiplied by minus sine of beta. Okay, we'll show more steps if you need to. Therefore this negative and that positive becomes negative, so cos of alpha cos of beta minus sine of alpha sine of beta, and therefore you've shown the identity. Okay, now 6.1.2 says simplify completely, and then they've given you there cos of 6x cos of 4x minus cos of 10x plus 2 sine squared x. Okay, so we've got to use identities here as well. Okay, but the trick here is identifying this here. Okay, because sometimes you look at this and we go, okay, cool, well I can change that to a cos. Okay, but then what's that going to help me if I change that to a cos? Well, at this case, not really anything at the moment. But if you look at this, we know that 10 is broken up into 4x plus 6x. So why am I doing that? Well, on this side I have a cos of 6x and a cos of 4x. So if I can break this up and then use my identity rule in the top, because it's 6.1.2, so we can still use what we've done in 6.1, okay, we might be able to simplify this. So I'm going to write this as 2 cos 6x cos 4x, okay, minus cos of 6x plus 4x plus, okay, so that's a 4 plus 2 sine squared x. Okay, so now by doing that, we can see we have a double angle over there, and we have a rule, or we've just proven the rule for a double angle for cos. Okay, so we know that that is going to just equal to this whole thing over here. So let's substitute that in. Alpha is going to be 6x and beta is going to be 4x. So it's going to be 2 cos 6x cos 4x minus, keep it all in brackets so that you know you need to distribute that negative afterwards. That's going to be cos, okay, alpha is 6x, cos beta is 4x, okay, then minus sine of 6x, okay, and I have to run across this side, then that's going to be sine of 4x, okay, close bracket, plus 2 sine squared x. Okay, so yes, it's nice, you can see that one, it's quick to jump to changing that, but sometimes you don't need to change the sine squared. Okay, now we can see if I distribute this negative in here, I'm going to have 2 of those minus 1 of those, and then this is going to become plus. So I'm going to end up with cos 6x, okay, cos 4x. Why? Because I have 1 apple over here and 2 apples, so 2 apples minus 1 apple gives me 1 apple. Okay, then negative and negative becomes plus sine of 6x, okay, sine of 4x, okay, plus 2 sine squared x. Okay, now that I have that, you can see that I'm dealing with a double angle over here, and guess what? They gave us this over here in the beginning. So we can now compact this down into cos alpha minus beta. Okay, so therefore we're going to end up with cos of 6x minus 4x plus 2 sine of 2x. Okay, so now we get down to that over there, and 6 minus 4 then just gives you 2. So we end up with cos of 2x plus 2 sine squared x. Okay, now we can use our identity. We know that cos 2x can change into something with sine in it. Okay, so if you're going to check that, you're going to get cos 2x can change into 1 minus 2 sine squared x plus 2 sine squared x. Aha, now we can sort out the sine squared. So minus 2 sine squared x plus 2 sine squared x, that cancels out, and we're just left with 1. Okay, so it's key to use what was given to you. There's a reason why this question was under 6.1 and that identity we proved early on. Okay, therefore let's look at 6.2. Okay, 6.2 says determine the general solution of the following. So we have tan x equals to 2 sine of 2x. Okay, always put your x's in brackets. It does just make things a little bit easier. So we've got some simplification that needs to be done here, because at this point in time we actually don't have anything to work with. Okay, because we have a function equal to a function. If I take this over, we're still going to have a tan and a sine function equal to 0. So let's simplify. We know that tan can break into sine of x plus cos of x. Okay, most of the time if there's a tan, we have to break it up into a sine and a cos of x. That's going to be equal to 2 sine of 2x. Now let's have a look. Can sine of 2x, does it have a identity? And indeed it does. It's a double angle identity. So we have sine of x over cos of x equals to 2 times, and then the identity becomes 2 sine x cos x. Okay, so now that I have that, we're starting to create numbers. Okay, so it's going to be easier to simplify things. Okay, so the next thing that I can do is I can multiply that across, okay, which means I end up with sine x equals to 4 sine x cos squared x. Okay, because I multiplied it across. Now that we have that, okay, we can now write it all in terms of one side. So we're going to have 4 sine of x cos squared of x, okay, equals to 0. Okay, and we can simplify this by taking out a sine x. Note I didn't cancel out sine x on each side, okay, because I need the sine x. So what's going to happen, what have I forgotten here? That should be minus and then plus sine x. Okay, so it doesn't matter which way you write it round. So therefore I can take sine x out as a common factor, and then I'm going to have 1 minus cos squared x equal to 0. So therefore we have, let me just box this off, we have sine of x equal to 0, or we have 1 minus cos squared x equal to 0. Okay, so now that we have that, we can solve the 2. Sorry, that's 4 cos. Okay, now we can solve that. So okay, let me just redo this here. So when we do the general solution for sine of x equal to 0, okay, so then if we take sine of, or the inverse sine of 0 equals, then if you put that in, you're going to see you're going to get 0. Okay, but we know that a sine function is repetitive every 180 degrees. Okay, so 180 degrees, so there's 90, that would be 180. Then 180 again, we're sitting at 0. Then 180 again at 0, so on and so on. So therefore, we then say the solution is x equals to 180 degrees, okay, plus k times 360 degrees, okay, where k is an element of integers. That's what that z stands for. Now, if we sort out this over here, we're going to get cos squared x equals to 1 over 4, okay, and then if we sort that out, we're then going to get, okay, so this is still going to be negative, so if we square root, we're then going to get cos of x equals to negative a half. So now if you plug that into your calculator, shift cos of negative 1 over 2, okay, you're then going to get 120. So x equals to 120, okay, but we want the general solution, so therefore we know that the cos graph as well is going to have a repetition, okay, every 360 degrees in this case, so therefore it's plus 360 degrees times k, where k is an element of integers. Okay, let's see if we just want to check something, delete, okay, that's 60. Okay, so the other one is then, if you had to double this over here, so if you had to say 360, 360 minus 120, okay, you're then going to get 240. So therefore the other one is x equals to 240 plus k times 360. Okay, why? Because if you check both of these, okay, on the cos graph, okay, so cos looks like that. Okay, so cos of 120 is going to be sitting down here, but then if we take 360 minus 120, we're going to be sitting there, which is the exact same value. Okay, so therefore we end up with both of those where k is an element of integers. Okay, so that's how we do this question. Okay, if you found today's video helpful, then please leave a thumbs up on the video. It does help me out a lot. If you have any questions, please leave them down in the comment section below. I'll get back to them as soon as I can. If you are enjoying the content, then please do consider subscribing to the channel. And remember, it's never too late to have an OIC moment.